What if the Earth spun the other way? Imagine waking up tomorrow and seeing the sun rise in the west. Something has happened overnight to reverse the Earth's rotation. Of course, our planet currently spins at more than 1,000 miles per hour, so suddenly putting the brakes on and reversing would have immediate catastrophic impacts. But if you did somehow survive the violent winds, tsunamis and earthquakes and waited for things to settle down, the first thing you'd notice is a change in the weather. The Earth's rotation means that we experience an apparent force known as the Coriolis force. This deflects the direction of the wind to the right in the northern hemisphere and to the left in the southern hemisphere. So, a reversed or retrograde spinning Earth would have retrograde spinning lows, highs, hurricanes and typhoons. Trade winds and jet streams would also reverse. Prevailing westerlies in the mid-latitude would become prevailing, you've guessed it, easterlies. But apart from being confusing for weather forecasters, how would a global wind reversal affect the long-term climate? In 2018, a team of researchers at the Max Planck Institute for Meteorology in Hamburg attempted to answer this question. They ran a computer simulation in which they forced the Earth to spin the other way and then watched the impacts play out over a 7,000-year period. As might be expected, one of the biggest climate shifts occurs in Northern Europe, as the beast from the east becomes the prevailing wind. In the UK, although the sun is the same strength as before, winters are now more than 20 degrees colder. Our mild but rainy climate switches to harsh polar tundra, similar to present-day northern Canada. If you'd prefer to head south for warmer climes, you'd need to get your skates on. The English Channel would freeze over during winter. Not that the Mediterranean would be any more appealing during winter. This is where many of the storms end up. Currently, in a normal spinning Earth, deep areas of low pressure form over the North Atlantic, where there is a steep north to south temperature gradient, and move northeast between Scotland and Iceland. In this alternative reality, the storm track takes a very different route, from between the Caspian Sea and Arabian Sea, through the Mediterranean and into the Atlantic from the east. The Costa del Sol becomes the Costa del Viento. Not only do atmospheric winds reverse, but ocean currents do too. The biggest victim, except for all the disorientated fish, is the Atlantic meridional overturning circulation, which currently transports heat and moisture around the planet. Whilst this circulation shuts down, a similar one emerges in the Pacific. Eventually, over thousands of years, changes in trade winds and ocean currents result in a more densely forested world with 25% less arid land. The South Asia monsoon moves west to affect the Middle East, and woodlands and grasslands start thriving across the Sahara Desert. Forget the Amazon, the world's largest desert is now east of the Andes in Argentina and southern Brazil. Southeastern USA also turns hotter and drier. The Everglades dry up. Florida's alligators would need to find a new home. Thankfully for Florida's alligators, Spain's tourism industry, and English Channel ferry crossings, the Earth is unlikely to change its spin anytime soon. But simulations like this can tell us a lot about how the atmosphere and oceans interact to give us the climate we experience today, and how sensitive they might be to any abrupt changes in the future.